Welcome to my talk on actioning observability with service level objectives, or put more succinctly, just actionable observability. And so my name is Lesley Cordero, and I'm currently a tech lead at the New York Times for its observability team, which sits under our wider platform and reliability engineering organization. And so before I get to what it looks like to action on observability, I first want to establish some shared language around what observability even is. And so while this talk isn't specifically about observability, because we're building on top of that topic, let's first review what I even mean when I say observability. And so as much as I hate repeating words on a slide, I'm going to do it if only for emphasis. And so borrowing Liz Fong-Jones's definition of observability, observability is the ability to understand what's happening inside of your software systems to debug problems you've never seen before, just using the telemetry, which is traces, logs, or metrics emitted by your applications. And more importantly, she says, it's also not just about a specific tool, it's about a team's ability to analyze that telemetry data. And so this is a loaded definition, but there are some components here that are important to highlight. And so first is this part about being able to understand the internals of your software systems just using telemetry, which is just data that represents the inputs and outputs of your systems. And so we most commonly know these to be logs and traces and metrics. And the reason for this is because the hardest and most interesting problems in software are the ones that we've never seen before, right? But it's incredibly hard to predict what specific issues we're going to encounter during the development phase. And so the better alternative is to equip ourselves with the right data, tools, and most importantly, the support to set ourselves up to build our skill sets. Which is why this last part is what really distinguishes observability. The most important part of observability and doing it well is that we understand how to use our telemetry to figure out how and why our application is behaving the way it is. And this can be hard enough for any application, right? But it becomes even more difficult as our applications grow in complexity. And complexity makes everything so much harder, right? It makes building applications harder, and it definitely makes debugging applications harder. And complexity makes development so much harder, right, that we as a collective industry have evolved the ways that we build applications. Just like we've evolved the way that we build applications to embrace the distributed architecture patterns, we must also evolve the way that we debug applications to embrace this full definition of observability. And this last part is what leads us to the actionable part. And so during the rest of this talk, we'll review the strategies that enable us to action on a telemetry, particularly during the moments when we need this information the most, which is the incident management cycle. And so again, let's provide some shared language on what it looks like to action on observability. And so the first part of this definition just restates basically what we reviewed, which is that telemetry provides the foundation by which we transition from data collection to action. And more specifically, the process of identifying, debugging, and addressing technical issues that are within our systems. And for this talk specifically, we're just going to focus on production issues. There are other ways to action in other environments, but that's going to be out of scope for this talk. And so going back to the three actions, which again are identify, debug, and address, this will provide the framework for how we roughly define the incident management cycle. And so we'll come back to this drawing that you see in the corner in just a few. And so ultimately, all the work to action on observability and improve our incident management process is done in the name of improving reliability, right? Users want reliable application experiences. And so it's our jobs as technologists to be intentional about how we can prepare for when our systems do end up being impacted by failures. And so before I go into the depths of the incident management cycle, let's briefly go back to our definition of observability. And so in this definition, we mentioned how debugging any application is hard enough, but that it becomes even more difficult as our applications grow in complexity. And so most of this talk is going to be primarily focused on my experiences within distributed systems, where complexity grows so quickly that there are too many ways for things to go wrong, right? Distributed systems tend to have so many dependencies and therefore so many risks. And so much like we use specific strategies to scale our applications, we must also use specific strategies to scale the way that we identify, debug, and address production issues. And so because of that, one theme that we'll see throughout this talk a lot is the role of automation, which improves our incident management process by reducing human error and improving our efficiency by translating manual tasks into streamlined processes using tools or technology. And so this means thinking critically about the type of work that doesn't require system-specific knowledge, and figuring out whether that's work that can be replaced by software that does that work for us. And so to summarize the benefit, automation acts as a consolidation technique to eliminate work that we often refer to as toil while removing the risk of drift. And so in this, right, we get to reduce cognitive load to focus on parts of managing incidents that can't be automated away, like the skills that we need to productively debug our application systems. And the type of work that's important but can be consolidated or in an automated or centralized way is work that is often repeatable or manual, which is again what site reliability engineering often refers to as toil. And so in this observability definition that we reviewed earlier, I emphasized the importance of a team's ability to analyze telemetry data. And this is the part that can't be automated away, right? Because learning and building up knowledge and building up a knowledge base are things that we just can't automate away, at least not yet. Maybe with AI, but we'll see. Now, that said, right, we have to hold that intention with not overloading ourselves with too much context. And so when I say that the goal of the automation, it really should be to manage cognitive load, not necessarily eliminate it, right? We can't get out of that. Because while we can't avoid cognitive load altogether, right, it can contribute to burnout, whether that's in the form of emotional or intellectual or even physical, right? And that's because unnecessary cognitive load is distracting, right? It impedes our ability to effectively debug production issues because it impedes our ability to make high-quality decisions during a time that's already pretty stressful, which is incident management. And this leads us to the last role of automation, which is to make better decisions. And so especially as our software grows in complexity, unmanaged cognitive load has serious long-term consequences, both cultural and technical. It's easy to fall into a chronic cycle of distraction, which means that it can be easy to fall into a chronic cycle of having teams whose ability to analyze telemetry data isn't best described as strong, right? And this is because the more cognitive load we have, the harder it is to make intentional decisions that improve metrics like time to restore service and reliability, some of the core metrics of success that comes from the DORA metrics frameworks, for those of us who are familiar with it. And so when both efficiency and good decision-making is tied to improving the reliability of our systems, right, we need to then be intentional about preserving that intention by eliminating or automating work that only serves as distraction. Which leads us back to the incident management cycle that I mentioned earlier, which I'll roughly again define through 3 phases of resolution: identify, debug, and address. And so we'll talk through each of these phases for most of today's talk, and both what this cycle looks like with and without the role of automation. And so let's dive in. Now, we're not going to discuss part 0 here, but I did include it just to indicate that a prerequisite for managing incidents effectively is having telemetry collection methods already in place, since ultimately, right, that's how our systems are able to communicate with us. And without this telemetry, right, there's not going to be any data for us to exercise the debugging skills that I keep emphasizing. But this talk isn't about telemetry, right? This talk is about the relationship between observability and monitoring through the lens of the incident management cycle. And so first, we have issue identification. And so this is exactly what it likely sounds to you. It's being able to identify production issues so that we're able to fix or address them and minimize the impact on reliability. Sorry about that. And so without the efficiency of automation, what this looks like is needing to be glued to checking our dashboards all the time, right? Just to find issues just in case that they happen, which I think what goes without saying, right, isn't quite sustainable, both for our systems and for the individual humans who are responsible for operating those systems. And so I think I can speak on behalf of everyone probably when I say that I don't want to spend every moment of my on-call shift staring at graphs. That sounds horrible. I love to eat and sleep and food and just generally be a human. And I also love to do more proactive and preventative work that makes our systems healthy, not just spend my time on wasteful things and waste the most precious commodity of all, which is ultimately our time, right? And so this is why it's important that we talk about monitoring as a distinct component of managing reliability. Because ultimately, observability is a fundamentally human practice, whereas monitoring, at least to me, is more focused on the automated discovery of application issues, usually through system checks scheduled on intervals. And so in other words, right, monitoring automates the humans away from wasteful work or lower value work, whereas observability brings the humans together for that high impact work that we can't automate away. Now, it's hard to talk about monitoring without also talking about alerting. And so if we no longer now need to be glued to our dashboards like I showed before, then clearly we must have a mechanism in place for communicating when something might actually be going wrong, right? And so most of us probably already know what I'm referring to here. Being paged or alerted is how we ensure that technologists still have strong ownership and responsibility over the systems that we operate. But for those of us who have ever been on call, right, we're probably also really intimately familiar with the risk of on-call noise, right? Where noise is defined as alerts that aren't actually impacting user experiences, which is why we ultimately need a strategy for monitoring and alerting. And so this is where we'll spend the majority of the rest of this session. And so we'll talk through different approaches to monitoring and alerting, both traditional and modern, and some examples of what it looks like to apply these approaches. And so regardless of the intricate details of any given approach, though, metrics are going to be foundational to defining monitoring and alerting conditions. And so now we'll review some different metric categories that I use to guide how we do monitoring and alerting at the New York Times. So give me just a sec. So I break these categories up into roughly 4 categories, which is infrastructure metrics, service metrics, application metrics, and user experience metrics. Other people might call it other things. I will go through the definitions of each just so that we have clarity on what I mean for each one. So starting off with infrastructure metrics, these types of metrics represent the underlying systems and resources that an application runs on. Right? And so some common infrastructure metrics that we are probably familiar with are things like CPU usage and memory consumption and network throughput, disk I/O, server response times, et cetera, et cetera. And so as the name indicates, right, these metrics help identify bottlenecks, capacity issues, and performance concerns, but at the infrastructure level. Next, we have service metrics, which focus on the performance and behavior of a specific service within a greater distributed system. And so they tend to provide insights into inter-service communication, latency and error rates and throughput. And they're crucial for understanding the health and efficiency of individual services. They're also useful for identifying issues that might impact the overall system architecture, since ultimately it is a dependency of that architecture. And to clarify just a little bit more here, the infrastructure metrics that we talked about in the last category are distinct from these because multiple services can be used on the same infrastructure, right? So for example, multiple services might be sharing resources like CPU or memory, disks, et cetera, et cetera. And so that's where that's what distinguishes the two, especially in the distributed architecture. And next we have application metrics, which are where things start to get a little bit more fuzzy because the definition of an application isn't quite as clear as it is for infrastructure or service. And for me, a service I basically define as like an independent deployment and independent unit of deployment. But regardless though, right, these types of metrics provide insight into the behavior and performance of an application as a whole, which in the case of distributed systems usually means that it's multiple services. And so instead of just focusing on service level metrics, application metrics approach it from a more user-centric point of view. And in terms of specific examples, we tend to see a lot of the same ones as we do in the previous categories, particularly the service level metrics, like error rates and resource utilization, latency, et cetera. It's just that the context of the metrics are what's different now. And so really the difference is that these have a wider technical scope, right? And that's because they're more reflective of the type of user experiences that your users are having. And so to make this more concrete, you can and should collect latency at a service level, for example, but the actual user impact of that latency isn't always obvious, right? Like, is it actually a bad thing if a request is 200 versus 300 milliseconds? I don't know about you, but I don't have a concrete answer to that, right? And that's hard to answer because without more user context. And so application metrics essentially try to get us closer to answering that question. Was there actually any user impact? And lastly, we have user experience metrics. And so these metrics measure the quality of user interactions within an application in a far more holistic way. And so these metrics are, they assess how users interact with and perceive the application, helping gauge like usability or satisfaction and overall user engagement. And some examples might be like customer satisfaction or conversion rate or time spent on a task, engagement, et cetera, et cetera. And so these are far more business-oriented than the others, and typically aren't ones that we should be alerting on, because they're more for business analysts or product managers than they are for engineers. But that said, they do provide important business context that can inform how we prioritize which metrics we choose within other metric categories, which we'll see is particularly important for service level objectives. Sorry, I went backwards. All right, next, we already have defined the action of monitoring, but we haven't really defined the monitor object, so to speak, which is basically just what represents the metric signal or signals that we deem important enough to alert on. And so while a monitor can exist independently of alerting, their effectiveness is pretty dependent on having alerting conditions that accurately indicate a system degrading, right? And so using everything that we've talked through so far, let's talk through what this configuration actually looks like. So I defined this process through 3 rough steps. The first being that we need to define the user experiences that we'll be monitoring on. And the asterisk here is because I'm using user somewhat loosely. Right? Any given team doesn't necessarily have the same users or even same types of users, even within the same company and even within the same product, right? And so, for example, I'm on a platform engineering team, which means that my direct users are actually my coworkers, who are engineers who use my shared infrastructure that my organization operates centrally, right? And since we provide shared infrastructure, the metrics that we care about the most are going to be biased towards infrastructure ones, right? Whereas product engineers developing Wordle, for example, are probably going to be biased towards caring about service or application level metrics. And again, this gets more complicated in distributed architectures, especially ones with multiple products like the times, because who's responsible for service level metrics versus application level ones gets a lot more ambiguous, right? Because ownership is harder. And so that said, I'll talk about addressing this tension with service level objectives later on today. And next, we have defining the metric or metrics that actually represent your user journeys. We already talked about metrics a lot, so I'm going to sort of skip to the next step, but feel free to ask questions afterwards if there was anything I missed. Cool. And then lastly, we have configuring alert thresholds. So alerts are what actually allow us to take an action, right? They're the signal, they're when we get paged. And ultimately, we need to be able to iterate on the specific values that we configure for our monitors, because our first go is probably not going to be accurate. So this actually ends up being a very iterative process. This is why we tend to see a lot of on-call noise or too much silence. It's usually because we're wrong in some direction, and that leads to a lot of false positives or false negatives. Cool. And so let's go ahead into an example. So when I reviewed step 1 earlier, I mentioned that the definition of a user is flexible, right? It doesn't necessarily mean end user. It might also mean other engineers within your company, like I mentioned with my platform engineering example. Another example of this is our core service teams, which maybe not all companies have, but I tend to see them as an organizational pattern. And they don't own infrastructure, but their users tend to be other engineers as well, because they're building service APIs that more direct end user facing teams are building on top of. So because of that, they're still, the main users that they're thinking about are still other engineers, just in a slightly different way. And so this is actually the example I'm going to use for, I'll use today. Cool. So in a theoretical example where there's a pub sub service that's responsible for sending notifications to other services when an article is published on a high traffic content provider, whoever could I be talking about? So, right, for this kind of service, what's going to be most meaningful are monitors that build off of service level metrics, for example. And so that's an example that we're going to use for the rest of this exercise. And there are many metrics here that we'll likely want to monitor, but let's think through how we can prioritize these metrics into alerts. And so for the Times or some other theoretical news organization, this service is really important because it's the service that we rely on to deliver breaking news, right? And when we deliver breaking news, that means people come onto our website. And when people come to our website, we have ads, and ads are what pay my salary. So this is why it's going to be important for the business. And having context like that is what's going to lead to more meaningful monitoring and learning strategies, and also more meaningful buy-in for when you have to prioritize reliability improvements, right? If you can tie your downtime to actual dollars, that's going to be way more meaningful language for C-suite or whomever than you saying, well, our downtime is up to X. That's bad. No one really knows what to do with that, but everyone knows what to do with money, roughly. So again, product context like this should be influencing the types of metrics and alerting thresholds that we choose, right? It might also mean how aggressive we are about what we alert on. And so based off that context, right, now we determine that delivery latency is our North Star metric, right? We want things to be delivered as soon as possible because we always want to be the first ones to deliver the news to any given person. Now, I already mentioned that real-time notifications are crucial for breaking news, right? So again, the thresholds should reflect that importance. And so that means we're going to want to be really aggressive for this monitor over the other ones that we might have. And we can do some pre-work to choose those thresholds by investigating the dependencies that the service might have and any historical data that we might already have. But in absence of this historical data, right, we can set up the monitor without some paging conditions and determine it from there. Or we can choose some arbitrarily and see what happens. And so this is where it becomes more experimental and iterative because it's hard to predict those things just out of the box. There's no book out there that says this is the right threshold that you should choose for this given use case, right? Everything has product context, which is why this is all so complicated. And so in my theoretical example, right, we do all that work and come to the conclusion that 250 milliseconds is a threshold we want to land on as our leading indicator and 300 milliseconds as the other. And to be more concrete, how we might choose those specific values within any historical data, right? We can investigate what the durations are at different interval points that can be also informative context. Now, let's switch over to what it would look like to monitor and alert on application metrics. So we talked about service metrics. Now we're going to talk more about application. And application metrics are more difficult to monitor on and action on because it's rare that one singular team owns the entire workflow. Sometimes that's the case, but as you grow larger and larger, often you're owning really small specific parts of any given user journey. And so this, again, makes it more difficult, but there are ways that we can get around this. And so now this is where we need to modify the way that we approach monitoring for these types of metrics. And so a strategy for that can manifest in the form of service level indicators and objectives. So service level objectives, or SLOs, they introduce transparency by defining concrete, agreed upon reliability targets. And so ultimately they clarify our expectations, our collective expectations around the reliability experience that we should be providing users. And so coupled with error budget policies, which define the actions that we take when we stop meeting those expectations, SLOs introduce an extra layer of accountability that makes teams more resilient to failure. And so the process of defining SLOs it's very similar to defining monitors and alerts as we traditionally think of them, but there is a fundamental mind shift that needs to happen when adopting service level objectives. And so let's go into what that looks like. So similar to monitoring, defining user journeys is also the first step. But you might notice I have prioritized here. And the reason I prioritize that is because we can only have so many SLOs, right? We really shouldn't, with monitors, it's more okay that you have tens and tens even per team, right? I know when I go onto our observability vendor, go into the monitors page, there's so many that are often not even configured correctly and whatnot. And I could probably delete most of them and no one would notice, right? Service level SLOs, if you delete it, everyone should notice. And that's because everyone should be thinking about those because they should ultimately be our North Star metrics that prioritize what reliability improvements we need to make. And so this is why I say prioritize, is because you need that sort of product expertise to figure out, okay, this is more important than this. Like cooking is less important than other product, et cetera, for the times. And so that prioritized part is really, really important, and also probably the hardest part, because that means you have to have a lot of negotiation of like what's actually more important to the business. And no one likes to be told that that what they're doing is less important than other things happening in the company, right? And so the process of it is horrible, if I'm being honest. I'm going through it actively right now. So starting with ads is pretty much always your easiest bet for anyone who wants a tidbit. That prioritized part is super important. Now, service level objectives, right? They should enable us to see above all of the noise that can come with having so many monitors in place, right? Like I said. And because we have concrete accountability mechanisms, those are budget policies, which define the concrete actions that we take when we use all of our error budget. This is why adopting too many SLOs can be too quickly overwhelming, right? If we have too many accountability measures for too many metrics, it's going to become too much of a rigid rule set for us to follow. Now, the next step that we reviewed in the monitoring section was to define our metrics. And so for service level, for SLOs, it's similar, but now we need to define SLIs, or several service level indicators. And so an SLI is a bit more specific term than metric, and it refers to the actual measurement of a system that represents your SLOs. And so the service level indicator should represent how we define reliability in the context of a given user journey. And there's a tendency here to assume that reliability is interchangeable with availability, but it's actually not, right? It's much more holistic than that. So much so that in 2021, the DORA metrics actually introduced reliability as its fifth metric to the framework, making sure to distinguish between availability and reliability in the report. And so instead, now we need to think about it more in terms of good versus bad events, right? Where bad events should reflect the set of events that we should consider a broken user experience. And so uptime, right, isn't the only thing that leads to a broken user experience. And that's why availability is not equal to reliability. High latency might also be considering breaking a user experience, right? So for example, right, if our latency is so high that users angry exit our product altogether, we might still consider that downtime, right? Like we're still losing ad revenue or whatever it is that we're optimizing for. And so there we can draw a line and say, we're still considering that downtime, even though it didn't return like a 500 error code, right? And this idea is repeatable for other metrics like data correctness or accuracy or the many more that you can be paying attention to here. Now, your definition of reliability might even include multiple metric dimensions, which I think now we're starting to refer to as composite SLIs or composite service level indicators. And so I'll actually use this concept in the example that we're going to walk through soon. And so once your service level indicator is defined, the next crucial part of adopting an SLO is defining its target. And this is different from monitors in that we're not choosing thresholds like latency this time. Instead, we're defining a value that's reflective of the percentage of observed good events. And this is, I think, part of why people think availability is equal to reliability here, because it's like out of 100%. And usually when we think like 99 out of 100%, we immediately jump to availability, but it's not, it's a little bit more nuanced than that. And so this target should reflect the aspirational reliability target, but to elaborate on my asterisk from earlier, if the current state of reliability is one that's far below your expectations, right, we also need to adjust in the beginning, either to accommodate like more flexible error budget policies or just lower the thresholds. What that looks like is ultimately a negotiation with your product partners and probably higher level either engineering or maybe even a company-wide leadership. And finally, we have choosing an alerting strategy. And so for service level objectives, there's roughly two camps of approaches to alerting. One that is consumption-based or burn rate-based rather. And the high-level difference between the two is related to error budgets that I kind of glossed over earlier. And so to elaborate on what an error budget is, it quite literally is like a budget, except the currency of that error budget is based off of bad events instead of money, right? And so in other words, right, your error budget reflects the number of events you can spend or have before you stop meeting your SLO. And so alerts based on consumption then refer to alerts that indicate the progress towards spending that budget. So for example, if you can set it up that you are alerted every time you're halfway through your error budget, or like 75%, et cetera, or when it's completely run out. Alerts based off of, let me just take a sip of water. Now, alerts based off of burn rates are basically off the rate at which you're spending that error budget, which is a little bit like meta. But in other words, right, alerts are triggered when the rate at which you're producing bad events is high enough that if you continue at this rate, you'll spend the budget that you have within whatever interval of time that you specified. And so a couple of notes here before I move on to the concrete example. Error budgets are usually calculated on a rolling window that calculates based off an interval of time. Usually you see 7 or 30 or 90 days. And the unit of measurement can also can vary in precision. It depends on how your approach and also the observability vendor. And so I'll elaborate on this in my example as well. Now, beginning with the prioritization, a given product will likely have a handful of SLOs, right? So we'll need to collaborate with product to determine which workflows in that product are the most critical. And within that, you might even want to stack rank the workflows in case you need to define follow-up actions based off importance. So for this example, we'll pretend that of our 5 SLOs, we're prioritizing serving an ad first because, again, money. And so next, we need to define our service level indicator. And when we think about the workflow, which to be more specific is that ads should be rendering whenever a user visits our content. There's a lot of nuance there because then you have multiple spots within a website. So you have to define the actual product scope more concretely. And this is why it takes so long to define things, to define SLOs, because the product surface areas can be vast. So defining what specifically you want to focus on is often a huge back and forth between different product partners and engineering. But so availability is going to be important here because, again, every time that workflow is down, we're actively losing money. And so in the name of defining a reliability more holistically, we'll embrace a composite SLI to include load time. So to summarize, right, we define a bad event to be any time that the request behind that workflow leads to errors and when the actual ad isn't rendered on the client. And so since ads is incredibly important because is incredibly important, right? The targets that we define are going to be on the more aggressive side as well. And so similar to traditional forms of monitoring, we have some pre-work here to do to investigate a reasonable optimal target. So for example, right, if our cloud provider only guarantees 4 nines, then we shouldn't be aiming for 5, right? At least not without spending a ridiculous amount of money that I really doubt anyone's CTO is going to approve, unless you're doing really important heart monitoring or something. But luckily for the times, it's not the case. But again, ads, right, is important. So we want to minimize instability to avoid concrete dollar loss. And so in production, right, we need to know when the workflow is unstable as soon as possible. So our alerting strategy is going to be optimized for precision. And so burn rates are far more precise because you aren't waiting for the budget to be gone before alerting. So that's the strategy we ultimately choose to land on instead of one that's consumption-based. And then next, sort of going back to where we started with the incident management cycle so long ago, these last two phases are significantly shorter, so we'll kind of just breeze through them and then head into questions. But next, we have the debug stage, and the issues that we find in production aren't going to fix themselves on their own, right? So once an issue has been identified, right, we'll need to debug our systems through investigation and analysis. And this is a stage that's often the most stressful to us, the humans, because of the possibility that we won't have a fix in place as quickly as we'd hope to, especially if we don't have things like automated rollbacks and whatnot. And unfortunately, there aren't that many ways to automate debugging, right? There's ways to make our system self-healing, but the actual debugging, right, that's still where we need to make sure that our skills are up to date, both in terms of actual practice and system knowledge. And this is, again, what emphasizes the importance of automation throughout the rest of the places, right? Because now we get to optimize for these phases that are where the human is far more important than like any automated system. And so next, right, for this process, right, there are other things that we can do to equip ourselves well, right? We can have things like dashboards, right, and things like query engines and da-da-da-da, and those are sort of ways, I guess you could say, like automate, right, in that I don't have to write a raw SQL query. Now I can go onto X vendor and just like maybe fiddle around with like filters and whatnot, right? But at the end of the day, we need to know like, oh, what data do I actually need to know? Like you have to be good at being able to ask the right questions so that it gets you to the answer sooner than later. And other things that you'll need to do, right, is like ask others for assistance, right? And that way we don't have to worry about as much. So that way, and the other thing that we'll have to worry about is asking others for assistance when it's something that is not like in our purview. So for example, like as a reliability engineering, a lot of times we're really just in charge for communicating and figuring out like who's the right people who should be in the room to debug the problem. And so that's like another source of strength that like you'll have to develop as an engineer. And again, these are the things that like we can help with tooling, right? We have PagerDuty to make it so that, okay, this is the point of contact of this team right now. But ultimately, right, we still need to know that like organizational or technical context. And again, this like ends up being cyclic, so this is just what that image indicates. And the happy faces indicate because now we're automating things and things aren't as quite as stressful as if we were like glued to looking at our dashboards and whatnot. And so lastly, we head into our address stage, right? Which is also what it probably exactly sounds like to you, just putting in a fix or fixes that address the system instability. And again, I mentioned automated rollbacks and whatnot as an automated way of like addressing issues, right? And so this is something that we can definitely do, especially with the metrics that I mentioned, right? We can tie the metrics that we define as important to kick off automatic rollbacks and whatnot. And so, sorry. Choking on water, I'm sorry. All right. Yes, so automated rollbacks. And the process is similar in that like you define thresholds again that would like have you automatically roll back any change. And this is important because actually I don't fully remember if this is the most up-to-date statistic, but usually the one that gets thrown around is that 73% of incidents happen because of a change, right? So eliminate 73% of your incidents by doing things with automation. And so from there, I think that's pretty much at the end. The one last thing I have to say is that I talked a lot about automation, right? But automation isn't supposed to replace the humans, right? It's supposed to enable us. And so I hope that's one thing that was clear. That's why I love observability more than monitoring, right? To me, I mentioned monitoring is more about automating things away. And observability is more of a fundamentally human practice. And so learning and being able to debug your systems effectively, both independently and together, is ultimately what I think makes the biggest difference for high-performing teams. And so I hope you all got something out of it. And feel free to ask me any questions.